So the three-dimensional problem is given a vector field F in Euclidean space of dimension 3. The question is there a function, I will denote it by E, I will call it potential function, on that three-dimensional space such that the gradient of E is equal to that given vector field F. Okay. So I will talk about the reason I call it the potential function later. Basically, the reason is that if you think about the vector field being the vector field of forces, for example, gravity force, then existence of such a function on mathematical side means in physics existence of potential energy, and you might want to, you might think that it always exists. No, it doesn't always exist. So in some scenarios there is no concept of potential energy, but for usual typical forces potential energy does exist, and that's exactly when you can use it, and I'll talk about the use of it later. Okay, so for now we stick with purely mathematical statement of the question. Given a vector field, find a function such that its derivative of the function is equal to that vector field. So basically the question is about existence of antiderivative of a given vector field. And the answer basically is that not every vector field has antiderivative. There are some vector fields so that there is no potential function. But we'll look into computational aspect of it. Right? If someone gives you a formula, so let me take a formula directly from the website. Here it is. Oh, let me do it this way. I will bring it to the screen. And I will ask someone to tell me what it is, so I can write it down here. And someone is, can please someone volunteer to read that for me?
2x squared.
F equals 2x squared
Plus y squared. Plus 3z squared. Minus xy. Minus 3yz. Plus 2x. Comma. 3x squared. Plus y squared. Minus 3z squared. Plus 3yz. Plus xz. Comma. 2x squared. Minus 2y squared. Plus 2z squared. Plus 2xy. Minus 2yz. Plus 2xz.
All right. So, well, the reason I'm taking the formula directly from the website is that if you choose a random formula, if you choose these functions randomly, with probability 1, the answer will be no. You will never find a potential function. So we will discuss later the reason why, but at this point, let me stick with this and just work out the problem. Now, well, we start with the question, what does it mean that this f, this vector field, is a gradient of something, is a gradient of a function? So if the function exists, the gradient of it is a vector field given by the partial derivatives. Right, so you have to put together all the partial derivatives of the function. And then this equals f means exactly that each component is equal to the corresponding component there. So as a result, we can write down a system. We're really talking about the system of three equations. The first is that Ex equals that first line, 2x squared plus y squared 3z squared minus xy minus 3yz plus 2xz. The second component, the derivative with respect to y of e, must be equal to 3x squared plus y squared minus 3z squared plus 3yz plus xz. And the last component of gradient is 2x squared minus 2y squared plus 2z squared plus 2xy minus 2z plus 2xz.